Hello everyone. In this video, we'll be talking about the classic lead code problem, container with most water, which is lead code number 11. So, what does the problem statement tell us and how do we go about solving it? It says that we've been given an array of integers of length n, and each element in this array represents the height of a wall. Now, that height is supposed to represent, like I said, height of a wall, and using any two heights in this array, any two heights, all right. We've been given multiple walls over here. We have to use any two at a time, and we have to form a container using them. And we have to return the area of the container that has the maximum amount of potential space in it. So they've used very fancy words like storing an amount of water in the container and returning it. And but the real problem that they've given to us is quite simple. They say that try to form a rectangle using these heights, and whatever is the highest amount of area inside such a rectangle, you return that area. And that's what you are supposed to do. Don't get confused with the wordings of the question, like container with most water. All they want you to do is they've given you certain lengths, and you have to find out the combination of certain lengths and the space between them to form an area which is maximum. And if that's still confusing for you, don't worry. I will clear it up for you by taking two approaches. The first of which will be the brute force approach. What does the brute force approach say? I say that you take one wall at a time, you try to form a container or a rectangle with all the other walls, and you see whichever is the maximum area in that case will be the answer. And you do this for all such walls. So in that approach, what we'll be doing is that we'll be first starting with this wall over here. We'll check what is the possible area formed with all the walls one at a time, and whatever is the maximum area will be our answer with respect to this wall. Then we will check the same for this particular wall, then this wall, then all the other walls that follow. So how do we go about it? We say that okay, we have this wall over here. First, we check the area that can be formed from with this wall as the left wall and the wall next to it as the right wall. So the rectangle formed by it would look something like this. Correct? So what is the maximum possible area that can be formed in this rectangle? So what is the height of such an area? Now keep in mind, this is where the wording of the question comes into play, container with most water. So you would say, why is this the rectangle being formed? Why are we not forming the rectangle in this manner? So to that, I would say that if you are trying to fill some water in here, right? If you're trying to put water in this container, as soon as it reaches this height, it will start spilling over. So that would not work out for us. So we have to take the height of whichever wall is lower in height. Between the two of them, it is the left wall. So we take 1. So we get the height as 1, and we take the space between them as 1 unit, right? Because this is at index 0. This wall, the right wall, is at index 1. So the breadth, the space between them, is also of 1 unit. So to simplify, the formula of area is length into breadth, right? So I'll just call this length over here. Although we do know that it's representing a height, and the area of such a rectangle would be 1. Alright. So our answer so far is 1. And after that, what we do is we will say, okay, fine, this is done. This combination is done. Let's move on to the next wall while keeping the left wall constant. The left wall will stay as it is. The right wall will be shifted to the one next to it. So the wall that is formed now would look something like this. Alright. In this case, the length would be the height of the shorter wall, as I just mentioned. This will be, again, between the two of them, the left wall is shorter, So we'll take its height as 1, which will be our length, and the space between them is 1 and 2. 2. Our area in that case becomes 2, and 2 is the largest area we've encountered so far. So we'll update that and move on to the next one. And we'll keep repeating the process. Well, we'll keep repeating the process till we reach the very end, after which we will try all the combinations for the next one. As soon as we've reached the end of the right walls, we will update our left wall to move to the next combination. Now, where do we start comparing? Which wall do we compare it to form the container? Do we do it with the left wall first, or do we just start from the walls on the right? The answer is the latter. We will start from the walls on the right because, as we just did, we have already made this comparison. We don't need to do it again, right? So we will now compare these two. Between the two of them, the shorter wall is this right wall over here. And so our height will be restricted over here with 2, let's say 6, right? It's 6, and the space between them is 1. So 6 into 1 gives us 6, which is the maximum area we've encountered so far. And this combination will, this process will keep on happening till we reach the very last wall. And in that case, what we'll encounter is, actually, you know what, before that, let's see this one. So in this case, we have one of the heights as 8, the other height is also 8. So the height stays the same, but the space between them is 1, 2, 3, 4, and 5. So 8 into 5 gives us 40 as the area. And in brute force approach, like I said, we test all combinations, and that is supposed to give us the answer with 100% surety. So we move on to this wall, and this will not give us a better answer because the height is quite short. And just to confirm, we have 8 into we have 8 as this wall, 3 as the height of this wall. The space between them would be 6. So 3 into 6 is 18, which is far less than 40. And of course, our answer is currently 40. Right? So we can scratch all these out. Then we move on to this wall right here. So between this wall and this one, we have the height as 8 over here, but the height is 7 on the right wall. So the shorter height would be 7. The space between them is 1, 2, 3, 4, and 7. That makes the area 49. That updates our answer to 49 because that is the maximum area that we've encountered so far. And of course, feel free to pause and try run all the other combinations. To save on time, I will give you a spoiler that the output is 49, which has been on our screen the entire time. But of course, you are most welcome to pause. You can try it for all the other combinations just for practice, just to get the intuition going. For now, I'll stop this process, and that is basically how we do the brute force approach. To explain how we would do it algorithmically, we would simply have 2 loops running for us. So the first for loop will run from index 0. It will go all the way till n less than n, and it will increment by 1 at each step. The inner loop, which will track the right wall, this is basically the loop for the left wall. The right wall, which will be the inner loop, will run from the place right next to the left wall. It will also go all the way till the end, and it will shift by 1 each time. And every single time, what we'll do is we'll simply get the area. The area will be the minimum of either one. So let's say we have our array known as H, right? This is our array. I say that minimum of the left height and the right height. This will be multiplied by the distance between them, the breadth, right? This is what we've been calculating so far. The breadth would be simply the difference between the 2 points, r minus l, or in this case, j minus I. So L is the variable I, R, the right pointer is the variable J, and of course the same goes here, right? So for simplicity, you can just write L in the initial loop, and then the inner loop you can write R if that is more convenient for you to understand. Now, that is basically how you do the brute force approach. But what is the complexity of such an approach? So, like I just explained, we are using two loops that are nested in nature. Nested loops, as we know, give us the complexity big O of n square. There is no space complexity, as in it will be constant, because we don't really allocate any extra space other than, of course, to store the answer variable. So the space complexity stays constant, and the time complexity is O of n square. So big O of n square. So my question is this good enough, or can we do better? I say that this is pretty good, this is pretty decent, this will get our answer. This may even work for you in a few interviews, but if your interviewer is as good as I am, they will ask you to optimize. They will ask you how can you do it in a manner that is even better, that is better than O of n square. For that, I will introduce the two-pointer approach for you. Now, in this approach, as would be quite self-explanatory, we will take 2 pointers. There is pointer 1, which we will place on the leftmost wall. Then there is pointer 2, which we will place on the rightmost wall. Alright. What we're supposed to do now is basically what we did before. We take the two walls, we take out the area between them exactly as we did before. For example, in this particular case, we have one pointer over here, the other over here. The area would be, well, height of the minimum wall, the shorter wall, and the space between them. So the height is 1 and the area is 8. So 1 into 8 is 8. And that is how we test one such combination. Now, how do we update our pointers? I say that if we're getting an area of 8, what we want to find out is an area that is potentially bigger than 8, right? Bigger or equal to 8, since we have to return the area that has the maximum area, right? That is maximum in nature. We have to return the container with most water. So I say that we will move the pointer in such a way that our area is potentially bigger. So I say that we have a height over here that is 1. We have a height over here that is 7. Oh, sorry, this is not, this is 7. So which pointer should be moved to potentially get a bigger area? I say that you move the pointer at which the height is shorter, right? Because if the height is shorter, we potentially move the pointer to a different point to see if we have a bigger height potentially. In that case, we will move the left pointer over here. And here, you'll notice that we get a different set of points. Comparing them, we see the exact same thing. The length is 7. The space between them would be 7. And the answer would be 49. This is the maximum area that we have so far. Now, we'll repeat the process. Whichever is the pointer that is pointing to the shorter wall, we will move that pointer in the direction that is more intuitive, so to speak. If we have the left pointer that is at the shorter wall, we move the left pointer forward. If we are at the right pointer that is pointing to the shorter wall, we'll move the right pointer leftward, right, backward. So in this case, we have this right wall that is shorter, so we'll move this over to the wall that is left to it. We'll keep on calculating the area in such a manner. For example, you have the height over here that is 3. The space between them is 1, 2, 3, 4, 5, 6. Right? This space will of course decrease by 1 every single time. That gives us the answer 18, which is not the highest that we have so far. Now, the shorter point, the pointer pointing to the shorter wall moves again. And here we have the height as 8, the distance between them as 5. That gives us 40, which is still not bigger than 49. And this is basically how we repeat the process till both pointers come to the same point. After which we will end the process, right? And that is basically how you calculate the answer using the two-pointer approach. And in the next video, we'll be implementing this in JavaScript. So stay tuned and follow for more.